So I got lots of like requests on help with some like homework, particularly on like constructing like Riemann limited sum. So I'm gonna do like a 5.1 extra videos here because 5.1 is kind of the most conceptual challenging part of method 25. And I just want to have more explanation for you just to how to solve this type of problem on the homework and the exams. So gonna be method 25. So we're still gonna be section 5.1. But this time I'm not gonna lecture in 5.1, so I'm just gonna actual materials, understanding how the homework. So we just construct the Riemann notation. And we learn in 5.1, we use like a midpoint, a left endpoint, and a right endpoint to approximate the area under the curve. And the notation for perhaps we have a function f of x, and we have interval a and b. We have n subintervals. And how to find not exact, but how to construct like a Riemann limit. We all know how to approximate, but how to write as a Riemann sum. And let's just begin. You all know what's like delta x. It is the width of each approximating rectangles. And the exact area, and we define as how to find exact area or approximate. We use like the definite integral, so this is going to be for 5.1 and 5.2. This notation b over a f of x dx, it is like a limit. Approaches infinity. Sigma notation. And what is xi? Is the ith approximating rectangle under the curve. Is a plus I times the width. So for example here, so it's like the ith approximating the rectangle under the curve. Perhaps we say f of x. Let's do an example here. This one is kind of like just asking the WebAssign homework. F of x equal to x squared plus it's like the square root of 1 plus x squared. We have an interval plus 2x. From x equal to 2 to x equal to 4, let's say. We do not have how many subintervals we have. So the width, it is delta x, it is 4 minus 2 over n. We have is 2 over n. It is the width. The xi, the ith approximating rectangle, it is a, it is 2, and we plus this I times 2 over n. What we have is 2 plus 2i over n. Here's our ith approximating rectangle of the area. So what we have it here, it is exact area from 42 f of x dx. We write as like a Riemann limit. It is a limit and approaches infinity, sigma notation, and I equals to 1 f x I, and then it's like delta x. Then we will have it is xi. It is this stuff. We put the xi is next type. We substitute xi we put the function f of x, and for this time substitute the 2 plus r x f 2 plus 2i over n. This is over x. So what we will have, it is the limit here have this x squared, so it's 2 plus 2i over n to the squared plus 1 plus 2x is 2 when we have x. It is 2 plus 2i over n times 2 over n is delta. That is the final answer. That, and we first find what is the width, then find what is the ith approximating rectangle. Then we use like a definition of the definite integral to use it to construct. Try another one. Perhaps g of x. It is the square root of x squared plus 5 from x equal to 1 to x equal to 5. When be x plus 5. This will be easier. And maybe pause the video, try this question on your own. Perhaps it is on the homework or the exam. Actually, so there can be 4 n is of a width. And the ith approximating rectangle, and what we have, it is a is 1, and plus is I of the x. Then what we have is a 1 plus 4i over n. Use the definition of the definite integral, the area under the curve, one curve, the exact area. And then we will have, it is still like a limit one gxi okay, x is the width. We substitute this as f of x. We write them as a function. G of 1 plus 4i over n times 4 over n. And then we plug this as an s. Then we will have, it is like the limit approaches infinity of this is going to be x, it's going to be one plus 4 over n 1 plus 5 times 4 over n is our final answer for this function. Another example here, we're going to do some kind of a harder example here. So perhaps a function is m of x. It is, okay, let's see another function. It's going to be x to the cubic minus 4 plus x to the squared from x equal to 3 to x equal to 9. So maybe pause the video, perhaps it's on the actual exam, and try to do this on your own, because this is the hardest part of the entire Method 25. If you If you make it through, then you do well on method 25. I trust you. Let's do it. Find what is like delta x. Then the ith integral, the ith approximating a rectangle should be 3 plus I times delta x. Should be 3 plus 6i over n. And the exact area it is like still a limit. Then what we have, it is a limit m times like delta x. It is 6 over n. We have is like a limit. Write this as a function. So this is x right now. Squared times like delta x. It is 6 over n. Is the final answer. Then let's try like another harder one. Serious, it's going to be a hard one. Okay. Example 4. For the previous example here, I introduced how to just write the limit as a definite integral, and now we need to see a Riemann limit, find the corresponding definite integral. In the previously we have the function, we write the limit. Now we do the reverse. Then evaluate. Now perhaps we have Okay, so this is a long limit. Don't be scared. This can be solved. There is an answer here. First we do from the width, from like the delta x. B minus a over n. So you have b minus 8 is 14. What we have is xi equals to a plus delta x. We have a equals to 2. So b equals to 16. And then find the exact area should be it's going to be f of x. It is like the limit and this function, because this is going to be the x, then we're going to rewrite the function as can be actually the fourth. Well, for this kind of integral, we haven't learned any advanced technique yet, but this is what we are targeting for, find the exact area, because this dude. Okay, that's all for the homework on 5.1 and 5.2. The next video going to be 5.2, which is definite integrals. Thank you guys for watching. Hope this helped you.